Hi, my name is Zhao. Very glad to attend to this workshop. Our paper is anomaly detection in railway transportation based on self-representation and generative adversarial networks. I'm the first author of this paper, and now I'm an AI researcher of INSPIRE Group. Other authors contain Rui Xue, Zhang, Qing, and Huang Yaping. They come from China Academy of Railway Science and Beijing Jiaotong University. And first, I will make a brief introduction about anomaly detection. The goal of this task is to divide anomaly from normal samples. In math, we tend to define anomaly as outliers because it's far from most normal samples in mapping space. In order to make it easier to understand, we can look at the right figure. When we define right dog as normal class, other kinds of animals such as horse and tiger are outliers in anomaly detection task. There are some similar tasks such as node detection, outlier detection, and so on. In fact, those tasks can be regarded as one-class classification problem. It assumes that it's difficult to collect enough abnormal samples, so only normal samples are involved in the training process. So that's why we call it as one-class classification. Anomaly detection can be applied to many fields in real world, such as medical image diagnosis, traffic anomaly detection, abnormal activity in video surveillance, and industrial inspection, and so on. In this paper, we research a railway boat anomaly detection task of real world. We collect a dataset termed as HRBDD. In this dataset, there are more than 20,000 normal boats. Among all them, more than 10 types of boats are collected from different kinds of components, so they are quite different in appearance. We also collect about 1,500 abnormal boats. There are more than 40 kinds of defects and abnormal conditions, such as missing bolt, untighted bolt, broken nut, and so on. So we can find it's not possible to rely on supervised learning methods such as image classification, object detection, and so on to identify specific categories of anomaly because we can't collect enough samples for each kind of anomaly. But anomaly detection method will be a proper solution for this task. In our proposed method MMAD, we designed a self-representation model termed as MM model. The main structure we can find it looks like an autoencoder with a separate encoder too. We also introduce a separately trained GAN to improve this model structure. We can see there are some notices and follows. And first, consider the drawbacks of the autoencoder, such as identity mapping. In our paper, we replace the decoder with a generator of GAN. A second, peak signal-to-noise ratio, usually known as PSNR, is applied instead of the pixel-wise method to evaluate the image reconstruction effect. And last, the model is constrained at the feature map level through semantic perceptual loss. With redundant constraint, the model therefore has a better performance. We can also see the pipeline of our method. And first, we need to train a GAN model. The function is to generate normal sample from latent space to image space. And then we need to train a MM model. In this stage, the parameters of generator and discriminator are fixed, so we only need to train the parameter of encoder 1 and encoder 2. And last, all the parameters of MM model are fixed in testing stage. In order to validate our model, rather than verifying it only on public datasets such as MNIST and CR10, our model also outperformed other algorithms in HRBDD dataset which are collected from real-world experiments. Can also show the noted last keynote is useful. You can see the introduce of PSNR and semantic perceptual loss is helpful for the performance of MMAD. We can also see the image reconstruction effect of MMAD in different kinds of dataset. At last, in conclusion, the pixel level of difference of image would be mitigated by some pixel, which can be suppressed by the introduce of PSNR. Second, autoencoder handle trinity of identity mapping. Using generator to replace decoder can improve the ability of model generation to some extent. And last, for one-class classification task, a certain degree of overfitting is beneficial, and limiting encoder 1 and encoder 2 by introducing semantic perceptual loss helps to improve the anomaly detection performance. That's all about our paper. Thanks for your attention. If you are interested with our paper, you can just connect me by email. Thanks.